Normally, a well-made neon tube can last for decades, but occasionally certain factors can cause the electrode wires to fail. These factors can include fracturing due to mechanical stress, corrosion due to weathering, burning due to high-voltage arcing, or any combination thereof. Electrodes with solid leads, called Dumet leads in the neon industry, are quite prone to fatigue, as shown here. Dumet leads have generally fallen out of favor, but many older tubes have them. Stranded wires are more durable due to their inherent flexibility, but they can also fall victim to failure over time. We are then left with a problem: a neon tube that is still functional, but no way to pass current through it. Our options are limited. With neon-filled tubes, the electrodes can be replaced and the tube can be reprocessed. Argon-mercury tubes are most often remade due to the hazards involved with reprocessing tubes that have contained mercury. A device called an electrode saver does exist. It is a long brass cap filled with copper wool, and they are designed for a quick in-the-field patch to get the sign working temporarily while a replacement unit is being fabricated. They are not designed to be used long-term, and they are only for use in enclosed signs with glass housings, never on exposed window signs or beer signs. One final option exists: chipping away glass from the electrode to expose wire that is buried in the glass. I have performed this repair successfully before, but this is considered a last-ditch effort due to the high possibility of failure. The procedure is easier on non-tubulated electrodes because there is more working area, but it is possible on tubulated electrodes as well. To get started, we will need a few supplies: gloves for cut protection, safety goggles as there will be shards of flying glass, and your choice of cutting implement. I prefer these. They are called tile nippers or mosaic nippers. Diagonal cutting pliers are more prone to sliding on the glass, but it is possible to use them. Some like to use a Dremel with a diamond cutting wheel, but this generates fine glass dust, and a respirator should be worn if this method is used. Now comes the moment of truth: breaking the glass, but hopefully just a little. We need enough of the electrode wire exposed so we can attach an extension, but if too much is exposed, it can compromise the glass-to-metal seal and cause the tube to leak. Remember, you can always remove more, but you can't replace it once it's gone. Note that taking too much glass in one bite can also break the wire along with the glass, which further exacerbates the problem. At this point, it is a good idea to check the integrity of the tube to make sure chipping the glass didn't create a leak. Our tube is still holding a vacuum, so we can proceed with soldering. Several small-gauge copper strands are wrapped around the electrode wires. A bit of flux is added, and the wires are soldered in place. Keep in mind that too much heat can cause the glass in the electrode pinch seal to crack, so apply heat for the shortest amount of time possible while still getting a good bond. A firm tug on the wires makes sure the joints are holding. At this point, the repair is complete. After cleaning up the flux, silicone and heat shrink tubing can also be applied to the repair to provide additional protection and strain relief. Once again, be aware that excessive heat near the electrode pinch seal can cause thermal stress fracturing. A final test on a transformer proves our repair was successful. Thanks for watching. I hope you found this tutorial helpful. If you have questions or comments, please leave them below. Hit subscribe for more neon-related videos, and we'll see you next time. As a bonus, I have included footage of how not to break the glass. Ooh! On this tube, I was overly aggressive on the first bite, and the vacuum was compromised.
Nope, looks like we killed it. I think we may have nipped a little too far.
As a result, this particular tube must be reprocessed.